What's good? We are back with another installment of our Philosophy of Mathematics series, and today we'll be discussing the concept of infinity, one of the most interesting, important, and misunderstood topics in all of mathematics. And first off, big respect to you for clicking on this video. That just shows how motivated, intelligent, and how well you have your priorities in line, that you're not just scrolling on Instagram Reels or YouTube Shorts looking for that dopamine hit. You're really breaking the trend and pursuing that education that it is so good for you, and that shows that you have the motivation and you are prioritizing and focusing your attention and action on the very best thing that you possibly can. So just enormous respect to you. Just thank you so much for tuning in, and my promise is that by the end of this you will know what the most advanced theory of the world has to say about the infinite, and that every idea you've ever heard about infinity, and by the way, almost every idea anyone's ever said about infinity, is absolute gobbledygook because they have their terms confused. Quick introduction, I'm Tommy, and CTMU Singularities, where the power of an individual meets a mindset of absolute truth. I help young guys get so self-actualized that they start figuring out the meaning of the universe. Subscribe right now if you want this and other similar content in your feed instead of whatever else you watch. Learn what school won't teach you. I've spent the last 3 years obsessing over learning the most advanced logical system in the world called the CTMU, and now I spend all of my time teaching other young guys how to conquer the world by becoming the most intelligent, educated, motivated versions of themselves that they can. If you're interested in further instruction, you can check out my paid community in the description. I don't take a single dollar from that. All of the money goes to supporting the CTMU movement. The lesson from this is don't make uncountably infinite deals. If someone says, and you'll know what that means at the end. So countable versus an uncountable infinity. A countable infinity is a discrete number sequence. That's like 1, 2, 3, 4, 5, 6, 7. And by the way, it doesn't matter if you can picture, you're at the, you're trapped in a room and the guard writes an arbitrarily large number on the board, and you have to keep guessing until you get that number. He could have written any number between 0 and infinity, but you have a way to get to that number. So you can just write the first day, you write 0, then 1, then 2, then 3, then 4, and eventually you'll get to that number. And that's what we mean when we say it's a countable infinity. It's a discrete number sequence. There is an exact number that we can get to that number. And the same applies if you go up in intervals of 1,000ths or 1,000,000ths. If you use that process where you choose one value and then the next value and then the next, as long as the series isn't continuous, you'll eventually reach that number. So that means that it's a lower, what we call cardinality of infinity. It's a lower cardinality of infinity than is a continuous number sequence. An uncountable infinity is, for example, the distance between 2 points. So there's an infinitely subdividable series, and whenever you take a subinterval of that, let's say instead from 0 to 1, you put 0 to 0.5, there is still an infinite number of points that we can pick out between those 2 points that we've selected. So there's no time where you're actually closing the interval. So it would take an infinitely times it. It's a higher cardinality of infinity because it takes longer to guess it. In fact, you'll never actually guess it using that series if you were to choose a number between 0 and 1, whereas choosing a number between 0 and infinity, where it's a whole number, it is. So the whole number sequence is a discrete number sequence, whereas the values between 0 and 1 is a continuous number sequence. But they're both infinite. But math is wrong about infinity the way that we usually talk about it, because it linearizes infinity, confining it to outputs and making it static, where, as we just discussed, the way that we're defining infinity and the way that mathematicians even implicitly define infinity is actually its input, is actually its process and its processing that it uses to iterate from one number sequence to the next. So mathematics linearizes infinity, confining it to like infinite sets, infinite sequences, infinite series. All of these things are static objects. The whole point of infinity is that it's not a fixture, but it's non-terminal. Anytime you define a set of numbers, it terminates on some finite but possibly colossal number. For example, the n-ary operation from n plus 1 from 0 to 1,000,000 is 1, 2, 3, 4, 5, 1,000,000 until you get all the way there. But with an infinite unbound interval, you count 1, 2, 3 and never stop. The series is non-terminal, but the process is the same. So any number we can define as the termination of an infinite process at that particular number. And it stops being infinite at the moment you put a boundary at it. So in infinity, we have to define as the unbound. In this sense, we can consider every discrete value on the number line as a terminal representation of infinity, the termination, the end of that sequence. And this is what Newton and Leibniz were onto with infinitesimals. Any continuous infinity requires the cuts in the number line to be quantized as a terminal expression of infinity, because you need an infinitely long series to approach a precise value, such as 9/7, 2/3, or pi. So an infinitary process is also a non-terminal process. Its lack of boundary defines it. So we define, therefore, infinity, either discrete or continuous, as something without a boundary, as something by which you've removed the boundary, either internally when you're trying to find the number of points between two lines, or when you're trying to find the total number of points that are discretely set apart from one another. Either way, we're looking at a process that has no boundary. Infinite sequences, such as those in integral calculus, can either be convergent or divergent, meaning that the area under a function from negative infinity to infinity can either be finite or infinite, depending on the function. So that kind of confuses what we usually think about with infinity, because how can something with infinite length have finite area? And the reason for that is because it is this process where it's continually lowering its length. And so you can say it's the same way where if you walk halfway to a wall and then walk halfway to a wall again and then walk halfway again, you'll never actually reach the wall because you're only getting a fraction there each time. In the same way, you can have an infinitely long sequence that never actually diverges to an infinite area. So that's what we might learn if we were talking about calculus. But the basic idea is that linearizing and fixing infinity into a set space is not okay, because infinity is dynamic. It only exists as a non-terminal process. The CTMU says that bound structure, actualization, and unbound structure, potentialization, is infinite. When something is finitely actualized and bound in a physical form, that structure is the self-restriction or termination of an intrinsically infinite dynamical process. Infinity is programming finite structures and its identity, properties, and relations. And this takes a whole new way of thinking about the world, is that we have to think of an infinitary domain, that is this world of design and potential that actually acts like programming does on a computer. And this is what Langen describes in the reality self-simulation paradigm, which we discussed in our series on mathematical metaphysics. But basically, just like a quantum wave function, the universe has an infinitary or unbound aspect, the wave function itself, or this realm of programming and design, and affinitary or bound aspect, which is the selected eigenvalue or the display of that reality self-simulation. And in a sense, the infinitary structure can be said to select or program the finite representation. So finitude is defined in terms of the universe as the display or the terminal domain, whereas infinitude is defined as the non-terminal domain. And these terms, which are borrowed from linguistics, are reflected in the mathematization of each of those things. That finitude is something that terminates at a particular point. So that process of n+1 will get to 3 after three terms in its series, whereas that series will never reach infinity except as the theoretical terminus of a non-terminal process. So reality self-generates from structurelessness, from this unbound infinitary structure. And this means that infinity is defined relative to syntax. It is defined relative to the structure and rules that it creates for itself in order to finitely and terminally represent the universe. So the first constraint on reality is unity, which is the simplest self-actualization. It defines itself with a pseudo boundary of being one thing, a terminal self-relation. And the next is infinity, because unity implies dynamical infinity, implies that there is never any actual termination to its continually changing internal structure. And so thus, the terminal and non-terminal domains are generated in coupling, just as are infinity and finity. So finite structure and infinite structure, or bound and unbound structure, are actually self-dual to one another, and they generate in coupling. So the key to metamathematics is to codefine infinity and finitude. It's to codefine the minimal and maximal structure scales corresponding to unary, so that's a 1, and infinity operators. So there are operators that work both at that scale of multiplicity, whereby there is this dynamical self-relation, and at that scale of unity, whereby there is this static identity. And the tension between those two things is what drives forth both mathematical structure as well as the physical structure of the universe. And this is expressed in the CTMU master equation, Rint equals Rx, which relativizes infinity and pushes it beyond its known limit. So it says that the intension of reality is self-dual, or it actually operates there's an operator that connects the intention and extension, or the internal and external aspects of reality. And the external aspects, the way that reality expresses itself, is defined as this infinitary self-programming, whereas the intentional aspect is the unary self-relation. So those are two things, but they're actually self-dual to one another. The only way to invariantly define existence that takes into account all of its changes in structure and dynamics is by coupling maximality and minimality. If the universe expands infinitely, then by definition, its evolution is n-ary. It's a non-terminal operation that continues happening infinitely into the future, and that must couple infinitary, inter-expanding, and finitary requantizing structures. So when we ask, like, is reality infinite or finite, the question is meaningless because the CTMU codefines finitarity and unitarity in the same operation. It is infinite with respect to our cognition, is that we can think of it as infinite. But with respect to our perception, with respect to that world that we actually can live in, it is necessarily finite because it is terminating on that which we are able to see. But in an ultimate sense, it is infinite. In the CTMU, an infinite valued logic arises whenever you have a non-terminal space of potential that is not yet collapsed as a terminal reality. Therefore, the non-terminal potential is infinitary in the sense that its logic does not have a true-false answer like two-valued logic, or a relative answer like more or less same as it does in multi-valued logic. But the non-terminal space of potential is generated as a truly open-ended question. So Langen says in his 1992 paper, The Reification of Many-Valued Logic in Infinity, that infinite valued logic arises as the terminus of an HSCS open inductive regression through arbitrary causal and compositional arrangement of these hypotheses. Therefore, objective potential is another term for multi-valued logic, and objective content is another term for one-valued logic, a constructive substance called telesis, or intelligent energy, that can actualize objective potential. When an object, property, or relation is defined by many-valued logic and registered by the human mind, the objective potential is collapsed to a subjectively defined and perceived one-value logic, i.e. the definite state of the system is observed without reference to its logical complement. So I can see this is this, and it is not something else. So that is when that multi-valued logic, that open-ended question, becomes, okay, well, that's the answer. So it's the relation between infinitarity and unitarity is the same as the relationship between question and answer. The construction of the universe through secondary telic informational feedback is an instance of collapse from many-valued logic, non-terminal telic potential, to one-valued logic, which is actualized potential, aka from infinitary to finite structure and dynamics based on the quantum information and observer participancy provided by secondary tellers, including human beings. Thus, infinity is defined in the CTMU as syntax relative, needing to be able to instantly scale the transition from infinite valued logic, pure syntactic potential, to many valued logic, which is a finite array of potential, to single valued logic, which is the actual content, the answer to those questions that valued logic has been asking, being closed with respect to the cognitive syntax of the observer and chooser at the level of the primary teller and secondary tellers as well. Thus, infinity is a non-terminal, self-potentializing, self-actualizing process. It is not a number, as we usually think about it. Mathematics emphasizes the self-potentialization aspect of infinity, thereby creating an inexorable dualism between infinity and finite numbers and processes, whereas in the CTMU, infinity and finite numbers are defined as expansions and restrictions, respectively, of syntactic potential. So when we say that something is infinite, we're just saying that we've removed its constraints. We've removed the rules and structure which say that it has to be one particular thing. It actually becomes the sequence itself of all the things that it could be. If terminal reality were not connected to infinite valued potential, this would contradict the informational stability of one-valued objects, processes, and relationships. These must be isomorphic. They have to share structure with the global identity of reality, which has both finite and infinite valued logical structures. So therefore, Langen says that the stability of each bit of recognizable information reflects its homomorphism, the way in which its structure is the same to the highest level identity, and thus to the informational totality thereby represented. So everything has the same structure as the ultimate identity of existence. And whereas identity is defined as syntax relative, it is relative, its structure and form and its content, ultimately, every object, process, and relation has to correspond to the non-terminal potential of reality itself. So infinity can't be defined as just this weird, like strange mathematical object that breaks a lot of the stuff that we use, but it is in some sense like the ultimate identity or the ultimate process of reality. So this is why infinity has such an important place in a lot of mystical traditions. For example, the Jewish mysticism defines God as the Ein Sof, the without limit, and there are a number of other examples. But basically, the infinite, which is without boundary, actually has to be the ultimate nothingness from which everything emerges. So it is something that is beyond syntax, is that which creates everything relative to it and within it. So where we have the syntactic definition of infinity, that infinity actually has to be able to create syntax, because there's nothing outside of it. There's nothing that you can say is outside of that infinitary process, because infinity by definition encompasses everything. So what that means is that the infinity actually internally generates self-representations, and that is what the number series is those terminal representations of infinity at any discrete value along the number line. Therefore, in the CTMU, infinity is defined as a syntactic expansion of potential and as a non-terminal or never-ending process. Infinity corresponds to unbound syntactic structure, and finite objects, processes, and relations are bound syntactic structures. Langen says, when we do this, treat infinity as non-terminal rather than statically infinite, we find that syntax-relative infinity corresponds to metasyntactic closure. The senses in which the CTMU is closed and open are thus properly distinguished in terms of the highest level inductive stratification. The CTMU alternates between being open and closed, or unbound and bound, corresponding to its states of syntactic self-potentialization. Infinity is defined as a non-ending process used to compute terminal processes with brute force, with infinity corresponding to the cognitive structure of the primary syntactor and finite objects, methods, and relations corresponding to the informational content of the universe. Therefore, infinity is defined in the CTMU as a non-terminal cognitive structure, which is conspicuously similar to how the programming domain of the reality self-simulation is defined. So basically, we're redefining infinity not as a number per se, but as the non-terminal domain itself. And then we can say, what is the non-terminal domain relative to our mathematical theorization? And that becomes a space of potential from which number emerges. So in fact, for CTMU theorization, one can treat the programming domain as infinity, embarking on a non-terminating infinitive computative cycle, and the display domain as finite objects, properties, and relations. The termination of the non-terminal process is defined by coupling it with the process itself. So all of infinity's self-terminations, which is every number along the number line, is a self-representation of infinity. It is a number along the sequence, and infinity is the process that creates that sequence, that n+1 that goes from 1 to 2 to 3 to 4 to 5, all the way up to infinity, ad infinitum, and then that sequence itself contains everything along the number line. It contains every discrete value possible. So therefore, the infinitely self-potentializing meta-object domain that generates the object's properties and relations within sensible reality is defined self-dually to what it is designed and displayed. Philip Davis and Reuben Hirsch write in The Mathematical Experience, significant mathematics is thought to emerge when the universe of discourse is enlarged so as to embrace the infinite. We have infinities and infinities upon infinities, infinities galore, infinities beyond the dreams of conceptual avarice. Infinity could be the striving towards realization and perception of the striving towards ultimate but unrealizable explanations. The infinite is that which is without end. It is the immortal, the self-renewable, the aperon of the Greek, the Ein Sof of the Kabbalah, the cosmic eye of the mystics, which observes and energizes us from the Godhead. And you'll be pretty shocked to hear this is not from like a weird alchemy textbook like Cornelius Agrippa back in the 1700s trying to like turn metal into gold or something. This is from like a math textbook. It's like from a book called The Mathematical Experience. It's a good book. I'd recommend it, but that's like pretty interesting that some of the cutting edge mathematicians are starting to catch on to the deeper implications of their work. It's the striving towards realization and perception of towards ultimate but unrealizable explanations. So infinity is defined as something which you can't reach the end of. It's unrealizable because it's unbound structure. It's very, very beautiful. So observe the equation 1/2 plus 1/4 plus 1/8 and so forth equals 1. The sum of the infinite series 1 over 2 to the n, where n takes up 1 every value up to infinity. So it's 1 over 2 to the 1 plus 1 over 2 to the 2 plus 1 over 2 to the 3. Does that equal 1 when you continue that series? You can definitely check that this doesn't equal 1 yet with just these three terms. It equals 0.875, but it's getting closer with each successive term, but it's never actually going to reach 1. The question is, if it's not going to reach 1 and it's not going to be any number in between 0 and 1, then is it 1? And this is a very involved question because it has to do with the question of like, is 0.9999999999999 and almost infinitely nines until it reaches the termination of that process at 1, is it ever actually equal to 1? And this is a big problem because it doesn't actually reach 1 until you have an infinitely long series of terms. So it's only when you apply that infinitary relationship, that dynamical continuing to do that non-terminal unbound structure to the 1 over 2 to the n series that it actually equals 1. And so 1 over 2 to the n with infinity eventually gets to equal 1. So here we observe a precise instance demonstrating our definition. The series 1 over 2 to the n equals 1 only goes to infinity because it is a non-terminal process. If it terminated at any point in the series, even at like n equals 10 billion, the series would add up to 0.99999 and so on, but it would never reach 1 exactly. Only at the infinitary level does striving become complete. Therefore, the fulfillment of finitude is by definition a non-terminal process. It can never be fully realized, but is a striving towards the infinite end. The 1 over 2 to the n sequence is a perfect example of the rint equals rx CTMU master equation. On the right side, you can see the equals 1. On the right side is the internal identity of reality. Remember, reality is 1 without any distinction or difference until we get to its internal contents. But with respect to its ultimate identity, reality equals 1. This is the law of 1. Reality is one entity, right? But on the left side are the terminal expressions of 1 that add up at the infinity category limit to the full expression. So saying that 1/2 plus 1/4 plus 1/8 and so forth equals 1 is basically the same as saying that when we get to the infinity category limit, the contents of reality and the structure of reality are one and the same. The only way Rx can be said to equal Rint is that Rx is operated upon by a non-terminal never-ending process that continually creates more dynamical representations of the 1. So the contents of reality can only be equal to the identity of reality if it is continually creating more dynamical self-representations. As Hirsch and Davis observe, we want to complete the incomplete, to catch it, contain it, and tame it. But the nature of the infinite is that it is open-ended. So we're always going to have this unbound structure, and it's better that we make peace than try to make infinity static or confine it to outputs. That's pretty asinine from the perspective of this advanced philosophy of mathematics. Mathematicians want to trivialize infinity. They want to confine we define infinity as a non-terminal process. Any attempt to complete the process, rendering it terminal, will lead to a non-infinitary process. To cage the infinite is to render it finite. Once mathematicians realize this, they'll stop treating mathematical infinities like static objects and treat them with the reverence that they deserve as the ever-flowing fountain of cold, fresh, living waters, never tamed, only to drink from and find rest from your finitude. As William Blake said, the purpose of man is the perception of the infinite. If the doors of open were cleansed, everything would appear to man as it is, infinite. It's only because we are perceptually bound beings that we need to see everything as having a boundary, as having bound structure, or else we would not be able to think about or perceive it. But in its ultimate sense, reality does not have to satisfy that requirement of our human cognitive perceptual syntax. So defining infinity as the non-terminal aspect of the reality self-simulation principle, Langan codified infinite quantity, infinite sequences, and infinite sets with a unified definition, saying that infinity, whether parallel or sequential, cardinal or ordinal, becomes the daunting prospect of any transducer embedded in or attempting to simulate another which has the capacity to outlast it, outreach it, or in any way contain or enclose it. Bernard writes, per the CTMU, infinity must be dynamized and made syntax relative, i.e. defined as a global property, distinctly recognized and actualized by local/finitary syntaxes. This allows us to codefine aleph naught, aleph 0, or aleph null, the smallest infinite cardinal number, with the infinite syntactic expansion of mathematics in the CTMU, a mathematical definition with great theological and metaphysical significance. Replacing the infinitary structure with the non-terminal domain and equivalently the finite content with the terminal domain, we can rewrite the CTMU master equation as reality infinite equals reality finite, where reality infinite corresponds to our syntactic definition of infinity, and R finite corresponds to the finite expansion of that sequence. Therefore, the CTMU restores the classical notion of infinity by self-dually defining a non-terminal process, infinity, with its terminal expression, any given number in the number sequence, defining infinity as the potential for a number. Infinity is defined as non-terminal potential, which plays a vital role in the universe's construction. Basically, Langen says, take the terms infinity and all. We use them to encompass totalities that we either cannot or would rather not enumerate. Thus, they are to some extent open with respect to content, yet they have well-distinguished closed-form definitions from those of other terms. Thus, it makes sense to speak of an infinite but closed universe and of a Big Bang and Big Crunch, which may be infinitely far away in the past and future, and yet identically distributed over time. By the way, eternity must be treated like infinity. It lasts long enough to encompass any discrete HSCS syntactified process, but is instantaneous at the identic level of reality. In fact, time and space as we know them arise only as the artifacts of metasyntactic restrictions. Without the attending inductive stratification, the universe is an atemporal, instantaneous flash of parallel self-differentiation. Therefore, according to that definition, the entire cosmos, all of space-time, is the self-representation of infinity. So there's a little bit to chew on for you little mathematicians. Thank you. Take care. Let the light shine forth in the darkness. May the peace of our Father in heaven be upon you. Like and subscribe. Peace.